Long before the first dinosaur took its very first step, before the skies echoed with the wings of giant pterosaurs, and before Tyrannosaurus ever ruled the land, there was another force shaping life on Earth. A force far more patient, far more silent, and far more deadly than any asteroid. We all know the story. A rock from space, fire, darkness, extinction.
It's clean, it's simple, it's wrong. Because the asteroid didn't kill the dinosaurs. Not alone. The real story of what ended 180 million years of dominance is stranger, slower, and far more terrifying than a single catastrophic day. Imagine standing on the shores of an ancient inland sea. The water is warm, the sky is clear. Dinosaurs have ruled this planet for longer than you can comprehend. And they have no idea that the ground beneath them has been preparing their extinction for millions of years, long before the asteroid ever arrived. So let's travel back 66 million years to a Tuesday morning that changed everything, and to the hidden killer that had been waiting for it all along.
This is not a dying world. "66 million years ago, Earth is warmer, wetter, more alive than anything existing today. The average global temperature sits 14 degrees Fahrenheit higher than it does right now. There are no polar ice caps. Sea levels stand 600 feet higher. North America is split clean in two by the Western Interior Seaway, 2,000 miles of warm, shallow water stretching from the Arctic Ocean to the Gulf of Mexico. Mosasaurs, sea reptiles the length of a school bus, patrol its depths. Pterosaurs with 30-foot wingspans ride the thermals above. On land, the food chain is stacked from top to bottom. At the very top, Tyrannosaurus rex, 9 tons, 40 feet long, a bite force of 12,000 pounds per square inch, the most powerful of any land animal that has ever lived. Herds of Triceratops, 12 tons each,
graze floodplains the size of modern Texas. Edmontosaurus migrates in herds of thousands along river corridors stretching for hundreds of miles. Dinosaurs are not struggling. They are not in decline. They are thriving. And beneath all of this, beneath the thunder of the herds and the shadows of the pterosaurs, hiding in burrows and root systems, are the mammals. The largest among them is the size of a house cat, warm-blooded, fast-breeding, almost entirely nocturnal. They have survived alongside the dinosaurs for 100 million years by staying invisible. On this Tuesday morning, not one of them has any idea that within 24 hours, the world will belong to them. But here is what the textbooks don't tell you. The dinosaurs were already facing a threat, not from space, from deep within the Earth itself. Halfway around the world, in what will one day be called India, the ground has been splitting open. For nearly 1 million years before the asteroid arrives, a volcanic province called the Deccan Traps has been erupting. Not a single volcano, a series of fissures stretching for hundreds of miles, pouring lava across the landscape in pulses. The scale is almost impossible to imagine. Over the course of roughly 1 million years, the Deccan Traps release enough lava to cover the entire state of Texas in volcanic rock more than a mile deep. The total volume exceeds 500,000 cubic miles. But lava isn't what kills, it's what comes out with it. Each eruption pumps billions of tons of carbon dioxide and sulfur dioxide into the atmosphere. Carbon dioxide warms the planet. Sulfur dioxide cools it. The Deccan Traps were doing both, and the climate was swinging wildly between extremes.
warming, then cooling, then warming again, for hundreds of thousands of years. Paleontologists have found evidence that dinosaur diversity was already declining in some regions before the impact. The Deccan eruptions had been stressing ecosystems for generations. The dinosaurs were not at their strongest when the asteroid arrived. Then, around 66 million years ago, everything changed. The object that appears above the Yucatan Peninsula is 6 miles wide and traveling at 40,000 miles per hour, 50 times faster than a rifle bullet. It has traveled 4 billion miles to reach this exact point in space. It crosses the atmosphere, 60 miles thick, in less than 1 second. In that single second, the air in front of it is compressed so violently that it superheats to 50,000 degrees Fahrenheit, 3 times hotter than the surface of the sun. The rock itself begins to vaporize before it even touches the ground. And then it hits. The asteroid strikes shallow water, just 150 feet deep, above sulfur-rich limestone. This location is catastrophically unlucky. Had it struck the deep ocean, miles of water would have absorbed the energy. Had it struck hard granite, far less sulfur would have been blasted into the sky. Instead, it hits the worst possible target: sulfur-saturated limestone, a chemical accelerant waiting to be ignited. The energy released is equivalent to 10 billion Hiroshima bombs, all detonating simultaneously. A crater forms, 110 miles wide and 20 miles deep. The rock beneath the impact does not shatter. It behaves like a liquid, flowing outward in a ring of mountains taller than the Himalayas, then collapsing back inward within minutes. And into the upper atmosphere go 100 billion tons of vaporized sulfur. This is where the real killing begins. The asteroid kills quickly. The fireball, the earthquakes, the mega tsunami, a wave estimated to be over 1 mile tall, carrying debris that geologists can still find today along the entire Gulf Coast. But these are not what caused the mass extinction. Not even close. The real killer is invisible. It rises into the stratosphere in the first seconds after impact, and it stays there for decades. The sulfur combines with water vapor to form sulfuric acid aerosols, tiny droplets suspended in the stratosphere, reflecting sunlight back into space. A layer just a few micrometers deep, spread across the entire planet, blocks more than 80% of sunlight from reaching the surface. The sky no longer looks like a sky. It looks like a ceiling. Flat, gray, featureless. Even at midday, only a dim, reddish twilight gets through. Photosynthesis begins to fail. Without sunlight, plants cannot produce energy. Without plants, the herbivores starve. Without herbivores, the carnivores have nothing to hunt. The entire food chain, 180 million years old, collapses from the bottom up. A Triceratops needs several hundred pounds of vegetation every day to sustain its 12-ton body. When the plants die, that food vanishes. Not all at once, but steadily, irreversibly. Within 2 years, the global temperature drops 47 degrees Fahrenheit. In continental interiors, it drops by as much as 65 degrees. Water becomes ice. Soil freezes solid. 75% of all species on Earth will not survive this winter.
For decades, scientists debated, was it the asteroid or the volcanoes? The answer, emerging from the latest research, is more disturbing than either one alone. The asteroid struck a world already weakened. The Deccan Traps had been stressing ecosystems for hundreds of thousands of years. acidifying the oceans, destabilizing the climate, pushing species to their limits. Then, the impact hit, like a hammer blow to a biosphere that was already staggering. And here is the most chilling detail. Recent studies suggest the Deccan eruptions actually intensified after the impact. The seismic shockwave, traveling through solid rock at 4 miles per second, may have triggered a new, more violent phase of volcanism on the other side of the planet. The asteroid from above, the volcanoes from below. Neither one alone would have been enough. Together, they were
Unstoppable. Yet life refused to surrender. The animals that survived were not the strongest. They were not the largest. They were the ones that could adapt fastest. The mammals, small, burrowing, flexible, emerged from their dens into a world without predators larger than themselves. Within 10 million years, every major lineage of modern mammals had appeared. Whales returned to the sea. Bats took to the air. Primates climbed through the trees of what would one day be called Africa. The reason you are here at all is that on a Tuesday morning 66 million years ago, a 6-mile-wide rock arrived from the outer solar system and found a world already on the edge.
The crater is still there, buried beneath the limestone of the Yucatan, silent for 66 million years. The fish at Tanis, North Dakota, killed within hours of the impact, their gills packed with tiny glass spheres of molten rock that rained from the sky, are still there, frozen in the sediment of that terrible Tuesday morning. And the story they tell of catastrophe and survival, of an ending that was also a beginning, is the story of every living thing on Earth today, including you. It was an ending, but also a beginning. If you enjoyed this journey into Earth's distant past, don't forget to like, subscribe, and let us know in the comments below. What extinction mystery should we explore next? The Permian? The Ice Ages? Something else? We read every comment. Thanks for watching, and we'll see you in the next adventure.